Hello and welcome to this third and last collaboration lecture in this course, Master in Artificial Intelligence. So in this, we will talk to you about an example of how a team worked together, the team of AI engineer, data scientists, software engineer, and domain experts, and how did they went go about developing a comprehensive AI solution that addressed the real world problem effectively. So this example is we will talk about in developing a comprehensive AI solution for predictive maintenance in a manufacturing facility. Now this solution aimed to predict equipment failures before they occur, reducing downtime and maintenance costs. The collaboration involved data scientists, software engineer, and domain experts working together with AI engineer to address the real world problems effectively. So how did they do that? Let's take a look at this. So they started the collaboration begin with the domain experts from the manufacturing facility articulating the problem of unplanned equipment downtime and its impact on production, which was quite heavy, quite huge. It was an old facility. Now the data scientists and software engineer collaborated with domain experts and to understand the requirements for a predictive maintenance solution such which required with its data availability, prediction accuracy, and integration with the existing system. So first they understood the requirements, the whole team along with the AI engineer. Then the data scientists work with the domain experts to identify relevant sensor data, maintenance logs, and other operational data sources. So they collected the data using these sources, the front sensor, maintenance logs, and other operational data source. And that was the work done by the data scientists in collaboration with the domain experts. Then the software engineers parallelly assisted in setting up data pipelines to collect, pre-process, and store the data in a format suitable for analysis. So the team was working together, you can see here, right? So data scientists collaborated with domain experts to facilitate, capturing equipment health indicators, operational parameters, and historical maintenance records. So a good amount of collaboration between data scientists and domain experts. Then they experimented with various machine learning algorithms and models like logistic regression, random forest, or deep learning, basically to predict the equipment failures. So they together they experimented with these various machine learning algorithms. Then the software engineers supported the data scientists in deploying scalable and efficient model by training pipeline using distributed computing peripherals and frameworks. Right. The team then developed a prototype of the predictive maintenance model and integrated them into a testing environment within the manufacturing facility. Right. And the domain experts validated the models by comparing prediction with actual equipment failures and providing feedback on the model's accuracy and usability. The engineers collaborated with data scientists to integrate the predictive maintenance model into facilities existing infrastructure such as supervisory control and data acquisition SCADA system and the maintenance management software. So they integrated this new model with SCADA and current maintenance management software. They developed API and microservices to expose model prediction insights to maintenance technicians and plant operators in real time so that these users could feed in the data, get the data output from the model and make use of that. So that's how the integration and deployment happened. So, working together, the team implemented monitoring mechanisms to track model performance, data quality, and drift over time in both model and the data. And to do that, they set up the alerts and notifications to flag anomalies and deviations from expected behavior, triggered the proactive maintenance actions or models needed as needed, right? So, as needed, they use these triggers to take right actions and model updates. So after deployment, the data scientists and software engineers and domain experts will continue to collaborate on an ongoing basis, basically to analyze feedback, identify areas of improvement, and iteratively enhance the predictive maintenance solution. They conducted regular retrospect meetings to review performance matrices, discuss lessons learned, and plan for future enhancement and adaptation to changing conditions. So, by collaborating effectively across the various disciplines, from AI to data science to software engineering to domain, the team developed a comprehensive AI solution for predictive maintenance that addressed the real world problem of equipment downtime in this manufacturing facility. Now, this collaborative approach ensured that the solution was tailored to specific needs of the domain, delivered tangible value, and evolved over a period of time to meet the evolving requirements. So, what do we do next? So, we will look at one of the last part, penultimate part of AI engineering, which is to do research and innovation. So, how does one go about conducting research, exploring the new algorithms and techniques, and improving the performance and efficiency of the AI world or AI models? That's what we will do in the next set of lectures. So thank you so much for watching this third collaboration lecture in this course, Master in Artificial Intelligence. I hope you're continuing to learn new things, continuing to enjoy, and I do look forward to seeing you again in the next set of lectures. Please do feel free to message me if you have any questions. I'll be happy to answer a question, and also download the PDF file to take a look at anything that is of specific interest to you.